Question 19. The activities and corresponding durations in days for a project are shown in the network diagram. Complete the table showing the immediate prerequisites for each activity. Indicate with an X any activities without immediate prerequisites. So the immediate prerequisite is the activities that are just before the activity that you're being asked to find the immediate prerequisites for. It doesn't include every activity before that up until the start point. So for B, let's look at this. B is this edge here. Are there any activities before B? No, because it goes straight to this point here. So there's nothing before it. So we can put an X there. Now, for activity E, let's change the highlight color. We go back to E and the node at the start of E, and there's two activities that go into that node, C and D. So over here, we're going to write C and D as the immediate prerequisites. Now for F, we look at F and that's over here. What is the immediate prerequisite for F? It's just E. E is the only thing going into the node that is just before the edge that represents F. So over here, we are just going to write E. So part B, find the critical path for this project and state the minimum duration for the project. So let's get rid of all this. To find the critical path, we can do our EST. So for the EST, we are looking for the highest values, because for the LST, we are looking for the lowest. L for lowest. So as we go along this network and we're looking for which option to choose, when we come to a node that has multiple edges going through it, we're going to choose the highest option. So at the beginning we start with 0, we'll go up A and this node is going to be 3. Let's go down B, this node is going to be 4. Now if we go down C from A, we add 3 because the activity time of C is 3. So this could potentially be 6. Now, if we go down B and then up D, 4 plus 5 equals 9. So if EST is looking for the highest, then the EST at this node is going to be 9. Now after that we have E, which is 5, so this is 14. And then 14 goes out to F or G, so if we go up F, that's 7, so this will be 21. And then over here, this node here has 2 lines going into it. So if we went from 14 through G, that would be 14, 15, 16, 17, or 26 if we go through H. So because we want the highest, we're going to take 26. So find the critical path and state the minimum duration. So the minimum duration is 26 because at the end of our EST, the final node was equal to 26 and the duration is represented in days. See, it says days here. Now, if we want the critical path, we have to go along the edges where the EST equals the LST. So if we were to go backwards, we would always start at the end and the EST equals the LST every time. That's how you start off. So if we go back through H, we subtract 5, so the LST will be equal to 21. And if we go back down F, we subtract 7 and this would equal 14. Now, if we were to go back through G instead, 26 minus 3 would be 23. And therefore this option would be 23. But for LST we go for the lowest, so it's 14. What this means is that this is going to be a edge that has a float time. And if an edge has a float time, it means it's not on the critical path. Now, if we go back from 14 minus 5, we get 9. And then now, if we go 9 minus 3, we get 6. And then 6 minus 3 is going to give us 3. So we have to go back to this one and check whether it's right. And then 9 here, if we go down D, minus 5 is going to give us 4. And then 4 minus 4 along B is going to give us 0. So if it's out of 3 or 0, we will choose 0 as the lowest. So far, we found that A, C, and G are going to have float times, which means that the critical path goes along here. So that means that the critical path is B, D, E, F, and H. Now finally for part C, it says the duration of activity A is increased by 2. Does this affect the critical path for the project, and give a reason for your answer? So if we increase A by 2, that means that this is going to equal 5. I'll do that in a different color. This is going to equal 5. So if this was to be 5 and we went through the path AC, that means that will be 5 plus 3, which is 8. Now then, this EST would be 8. But it's currently 9, and with EST we always choose the highest. So in that case, we wouldn't choose the path AC over BD, and so the critical path will still stay as BD. So what we're going to write here is no. If A increases to 5, the EST at E remains as 9. Since the path BD on the critical path is higher than the new AC path at 8. So we're saying no, if A increases to 5, the EST at E, which is this point here, when we say just EST, it's the node before. If we say EST next, it's the node after. So that's why we're saying EST at E remains as 9, which is what we said, since the path BD on the critical path is higher than the new AC path at 8, or of 8. And that would be our answer. And this is all of question 19.